a scale inhibitor in delaying precipitation of calcium carbonate in water treatment and distribution systems. Please carry on.
Thank you, ma'am. So in 2019, a letter came from Meherpur. The Meherpur Purosabha was experiencing some problem with their water supply pipes. Some white stuff was blocking the pipes. What were they? Well, they turned out to be calcium carbonate precipitation. Today, I will be talking about the effectiveness of zinc as scale inhibitor in delaying the precipitation of calcium carbonate, and I am Tahsina. Good afternoon, everyone. The problem statement goes like this. The calcium carbonate precipitation is not a new phenomenon. It has been present in industrial and drinking water sector for a long time. But in Bangladesh, due to recent climate change and temperature increase, the problem has been re-emerging. This white hard scale blocks our supply pipes, restricts flow, the pressure, there is a loss of pressure, then in the treatment unit, the membrane and the treatment equipment get depreciated. Yes, there are some available treatment systems for this. So let's see, how does this happen first? The calcium carbonate precipitates when there is too much calcium carbonate, then the water can hold, or the water can soluble. At pipe surfaces, when there is a foreign particle or a calcium carbonate particle works as a nucleus, and around it the calcium carbonate lattice forms. There are many different forms of calcium carbonate, but it finally precipitates as calcite. The available options that were tried were removing the calcium or carbonate ions. Well, we can remove the carbonate ion, but it adversely impacts the removal of iron and arsenic, which is abundant in Meherpur. So why not remove the calcium ion? It is possible, but this is very difficult as operational activity and very expensive. The third low-cost option is use of scale inhibitors, which will delay the precipitation and will keep the calcium and carbonate in the solution. There are some polymer inhibitors available in the world, but they're very expensive and not available in Bangladesh. Phosphate has been used as a low-cost inhibitor, but they pose some environmental problems like eutrophication. So we thought, why not zinc? Zinc has shown some properties that may be useful in inhibition. Our objectives were to see if zinc is actually important or actually effective in scale inhibition in electrolyte solution or synthetic water. We also observed the inhibition performance under varying degrees of supersaturation and mixing times. We did a total of 7 experiments. Each experiment had 10 samples. When preparing the samples, we first put in the carbonate ions, the calcium ions, then sodium chloride to simulate groundwater condition. Finally, we put different doses of scale inhibitor. The zinc ion was provided in the form of zinc chloride in 10 different doses ranging from 0 to 5 mg per liter. The samples were then mixed on a magnetic mixer. The mixing time was different for each experiment, ranging from 30 minutes to 5 hours. After mixing was done, the samples were taken out. They were filtered using a millipore filter. Then the filtered samples were tested for different parameters like pH, temperature, alkalinity, and final dissolved calcium. We wanted to see how much calcium stayed in the solution and how much precipitated. All the experiments were done in the Environmental Engineering Laboratory of GUET. So after all these batch experiments, what did we actually find? Is zinc effective? Yes. Our finding number 1 is...
You have 3 minutes left.
Okay, ma'am. Yes. Our first finding was that increasing the inhibitor dosage decreases the calcium precipitation. As we can see from our experimental graph that we are increasing the zinc concentration from 0 to 5. the final dissolved calcium is increasing and the precipitation is becoming almost zero. Finding number 2, that's the most novel finding of our research, that mixing time has a positive effect on inhibition. As we are increasing the mixing time from 30 minutes to 5 hours, we can see that there is a jump at 1 hour mark. As we are increasing the mixing time, zinc is more effective. But the third negative finding is degree of supersaturation does not help the inhibition effect. As we can see, let's see what happens at 2 milligram per liter concentration of our inhibitor. As we are increasing the degree of supersaturation, the precipitation is sadly increasing too. This is a summary of our research. Our two main limitations were that we did the experiments in electrolyte solution, not in raw groundwater. And the second is that our degree of supersaturation range was very narrow, as we only simulated the values we got from Meherpur Purosabha. In future, we want to experiment the effect of silica ion that might be on the inhibition performance, and it is also necessary to check the effect on actual groundwater before application. Thank you everyone. I would like to express my gratitude to my supervisor, Dr. Muhammad Ashraf Ali, and please ask any question.
Thank you, Tahsina. Very interesting presentation, interesting topic, and very essential this area of research. Thank you very much. I would like to request the participants to ask Ms. Tahsina. She has findings. She mentioned that she has novel findings. So if you want to ask, or if you want to know more details regarding her findings, you can ask. Okay, there is no questions from the audiences. I just appreciate you to do very good research. We are very close to our schedule, which is being scheduled to end at 3 p.m. So just one more, just a very simple questions from my side. Could you please go back to the slide on degree of saturation?
Yes, ma'am.
So, what was the find? Could you please repeat it?
Ma'am, degree of supersaturation has a negative effect on precipitation. As we can see that as we provide the same inhibitor dosage at 2 milligram per liter, but as we are increasing the degree of supersaturation, the precipitation is increasing. That means the inhibitor is not working well. Okay. Have few positive presence and few negative presence, right? Yes, ma'am. So you have to go further in this area. Yes, ma'am. Although you have got very neat results from the study, but you have to go further. Right? Yes, ma'am. We have done. We have actually completed another set of experiments after this paper was submitted. Okay. Okay. Oh, keep it up. Very best of luck. Thank you, ma'am. Okay. Thank you. Could you please turn off your screen?